Section 1.5, Linear Functions, Equations, and Graphs. In this section, we will learn how to identify linear functions, graph linear functions, write linear functions or equations given various information including slope and y-intercept, slope and a general point, two general points, and a couple special cases, horizontal and vertical lines, and parallel and perpendicular lines. Then we'll see a couple of applications of linear functions. So first, what is a linear function? A linear function is a function that can be written in the form f of x equals ax plus b, where a and b are constants. Notice that the x, the variable, the independent variable, is understood to be raised to the first power, not any other power. We're not dividing by the variable. We're not finding any root of the variable either. So let's look at a few examples and determine, is it a linear function? Now we might have different variables, but the same basic concept. All right, h of x is equal to x to the third plus 5. Is it linear? Well, we see the x is being raised to a power other than the first power. This is not linear. F of t is 7 plus t over 4. Well, we have t instead of x. Okay, well, we can deal with that. But what about that t over 4? Well, recall that t divided by 4 is the same thing as 1/4 times t. And so I could rewrite this as f of t is equal to 1/4 t plus 7, which is linear. X is equal to negative 5.5. So there's only one variable and it's only x. This is not linear. If we had just y equals, or just f of x equals a number, so if we just had f of x equals negative 5.5, that is linear. Y equals 8 to the x power. Well, we're only allowed to multiply the input by a number. We're not allowed to take a number and raise it to the x power. This is not linear. In fact, this is what we'll call exponential. And we'll deal with that in a later chapter. And our last example, y equals 18 minus 9x. Well, that's the same as y equals negative 9x plus 18. That is linear. And in fact, we already know a lot about linear functions because we've talked about linear equations earlier. And in fact, notice that f of x equals ax plus b is quite similar to y equals mx plus b. And so if we wanted to sketch f of x equals 8 minus 9x, we know that the slope is negative 9, and the y-intercept, the vertical intercept, is 0, 8, and we can use that information to graph the line. Assuming a standard scale, we have a y-intercept at 0, 8, and then the slope is negative 9, which I can think of as negative 9 over 1, so let the line fall 9 and run 1. Fall 9 and run 1. And we can draw that line. Poorly. Let's try again. Try and actually get through those points. That's better. All right, so there is the function. F of x is 8 minus 9x. Now we should really put x here, and we'll often put f of x on the vertical axis. So let's see an application of a linear function. Keith's Air and Heat business charges $65 for a service call and $55 per hour labor fee. The total charge to the customer is denoted by C of t is equal to 65 plus 55t, where t represents the time in hours and C of t is the total cost. That should be a capital C. Interpret the vertical intercept using a complete sentence. All right, so the vertical intercept is the y-intercept. And so then the y-intercept is 0, 65. Interpret the vertical intercept. The business charges a $65 service call. All right, because what is this point saying? T is the time in hours, C is the cost. 0 hours, $65. The moment they get there, they're charging $65 for the service call. Interpret the slope using a complete sentence. The slope is the 55. And that corresponds to the labor fee. The business charges $55 per hour for labor. What will the total charge be for 3 hours of labor? Well, then 3 hours of labor, T equals 3. So then C of 3, what is the cost after 3 hours? Would be 65 plus 55 by 3. Evaluating this expression, I'm using a calculator off on the side here, gives 230. Conclusion: the total charge for 3 hours of labor is $230. How many hours were charged if the bill was $175? So then the cost is $175. So we'll take the cost, which is 65 plus 55t, and set it equal to 175. I'll solve by subtracting 65 from both sides. So then 55t is equal to 110, and dividing through by 55, we find that t is equal to 2. So, if the bill was $175, then 2 hours of labor was charged. So now, how can we look at a table and determine if it represents a linear function? The key to a linear function is the constant rate of change, the constant slope. All right, so a linear function has constant slope. So what we can do to determine if various points in a table represent a linear function is determine the slope between the points. All right, so let's make another part to the table. Let's make a delta x row and a delta y row. And so to find the delta x, let's just look at the changes from -3 to -2. That's an increase of 1. From -2 to -1, that's an increase of 1. From -1 to 4, that's an increase of 5. From 3 to 4, that's an increase of 1. From 4 to negative 1, that's a decrease of 5. And from negative 1 to 0, that's a increase of 1. So now let's determine the slopes. As delta y over delta x, m would equal 1 over 1, which is 1. M would equal negative 5 over 1, which is negative 5. And for the third change, m would equal 1 over 5, which is 1/5. Is it linear? Well, for it to be linear, those need to be the same. Not linear. Let's look at another example. New table of data. Let's again create a delta x and a delta y. Negative 8 to negative 6 is an increase of 2. Negative 6 to negative 3 is an increase of 3. Negative 3 to 12 is an increase of 15. 18 to 12 is a decrease of 6. 12 to 3 is a decrease of 9. 3 to negative 42 is a decrease of 45. Now let's calculate the respective slopes. All right, between the first 2 points, we would have what, negative 6 over 2, and would equal negative 3. Between the second and third points, we would have m equals negative 9 over positive 3, which is also negative 3. And between the third and fourth points, m would equal negative 45 over positive 15, which is also negative 3. All right, so let's look at those. Since they're the same, this is a linear function. All right, so now kind of switching back over to linear equations, not so much with functions. What if we are given, we're trying to find equations of lines, and we're given various information. All right, so first, we have a line passing through 0, negative 5 with slope 2/7, and we're asked for the equation of the line in slope-intercept form. So recall that's y equals mx plus b, where m is the slope, and the ordered pair 0b, that's the y-intercept. So now look at the information we have given. 0, negative 5. So that tells me, since I've got 0, negative 5, that tells me that my b value is negative 5. Slope 2/7. M equals 2/7. So then y equals 2/7 x minus 5. So this was easy. We were given the information we needed for the slope-intercept form. But what if we're not given the y-intercept, and we still want the slope-intercept form? Well, when that happens, we have two options. Option 1, we're going to use the point-slope form of the equation of the line. The point-slope form is, if we have a line with slope m passing through the point x1, y1, we say the line has point-slope form y minus y1 is m by x minus x1. And all we do is we solve for y and simplify to get the slope-intercept form. That's our first option. We use a different form to get to the slope-intercept form. Our second option is we start with the slope-intercept form. We know the value for m. We substitute one of the ordered pairs for x and y. We solve for the b value and revise the equation. So here's an example. We're going to find the equation of the line in slope-intercept form given this information. We're passing through the point -1, -8 with slope m equals 16. So here's the first option, using the point-slope form. So using the point-slope form, we have the m value. My x1 is -1 and my y1 is -8. So recall that the point-slope form is y minus y1 is m by x minus x1. So I would have y minus negative 8 is 16 by x minus negative 1. Now it's usually easier before we do any solving to simplify, especially if we have those minus negatives. So I'll write y plus 8 is 16 by x plus 1. Now I want slope-intercept form. So I will first apply the distributive property, y plus 8 is equal to 16x plus 16. And now all I have to do is subtract the 8 from both sides. And y equals 16x plus 8. And there's the slope-intercept form using point-slope form. Our second option is to use the slope-intercept form and substitution. Alright, so I'm going to start by saying, well, I want y equals mx plus b. I know the slope is 16, so y equals 16x plus b. Now, I know it must pass through the point negative 1, negative 8. So let me substitute negative 1, negative 8. Alright, so negative 8 is 16 by negative 1 plus b. So then negative 8 is equal to negative 16 plus b. Now I need to figure out the value for b, so I will now add 16 to both sides of the equation. And then b is 8. So now I revise the model. Y equals 16x plus 8. I get the same thing either way. Personally, I prefer the first option, and that's the option I'm going to be using whenever I need to write a linear equation using this kind of information. Again, we want a slope-intercept form, but now we're given just 2 points. We don't have a slope. Well, but if we have 2 points, we can find the slope. So let's first find the slope. So m would equal negative 15, subtract negative 27, over negative 2, subtract negative 3. So recall that that would be then negative 15 plus 27 over negative 2 plus 3. And so that would be 12 over 1, which is 12. So now I have the slope, and I have 2 points. So now I'm going to use the slope and 1 point. Alright, so I'm going to use the first point. I'm going to use negative 3, negative 27, and the slope is 12. I'm going to use the first option that I presented earlier, the point-slope form. So I would write y minus negative 27 is 12 by x minus negative 3. So y plus 27 is 12 by x plus 3. Y plus 27 is 12x plus 36. And now I'll subtract the 27 from both sides. And y equals 12x plus 9. Now, just for sake of argument, what if I had used the other point? My equation would have been y minus negative 15 is equal to 12 by x minus negative 2. So y plus 15 is 12 by x plus 2. Applying the distributive property, y plus 15 is 12x plus 24. And subtracting 15 from both sides, y again is 12x plus 9. Alright, so as long as we find the slope correctly, it doesn't matter which of the 2 points we use in that point-slope form. All right, so here's a similar example as the previous one, a little bit tougher, but this would be a good one to try on your own if you decide to. Now would be a good time to pause. All right, so let's try it out. Let's find the slope. So the slope, m, would be -1 subtract 3/2 over 6 subtract 3. -1 subtract 3/2, well, -1 is 2/2, so that would give me -5/2 over 3. -5/2 over 3, that's -5/2 times 1/3. Division's multiplication by the reciprocal, and so then that would be -5/6. All right, now I'll use the slope and a point. I'm going to use the second point in this case because I think the arithmetic will be a little bit easier. All right, so let's try this out. So then I would have y minus -1 is equal to -5/6 by x minus 6. Simplifying, I have y plus 1 is -5/6 x by x minus 6. I'll apply the distributive property. Y plus 1 is -5/6 x plus 5. And finally, I'll subtract 1 from both sides, yielding y equals -5/6 x plus 4. So now I have that. It's always a good idea to check with the other point that we have. So I'll use a calculator to check in this case. So now passing through 3/3/2, so if I substitute 3 for x, I better get 3/2 for y. All right, so let's see, -5/6 times 3 and add 4, and I get 1.5, which I recognize as 3/2. If you don't recognize that as 3/2, now hit Math, change the fraction by hitting Enter and entering again, and we do see the 3/2. So when x is 3, the output is 3/2, and I'm comfortable with my equation. All right, here we're given a graph, and we're asked to find the equation of the line in slope-intercept form given this graph. So notice we don't have y, but we have c of n. So I want to write c of n equals mn plus b. No x, but n. All right, so let's first find some points, find some nice points. Now, the y-intercept, I'm not sure where it is. I know it's between 20 and 24. I could guess and say it's 22, but we don't want to guess. We want to be sure. So instead, I'm going to use more solid points. That's a solid point. I'm going to use -4/16, and this appears to be a solid point, 4/28. Find the slope. M is equal to 28 minus 16 over 4, subtract -4. 28 subtract 16 is 12. 4 subtract -4 is 8. And 12 over 8 reduces to 3/2, or 1.5 if you want a decimal. All right, so now I have not y, but c of n. And I'll abbreviate that c temporarily. So I'm going to use the slope and the second point, and I can write c minus 28 is 3/2 of n minus 4. Nothing to simplify here. I'll apply the distributive property on the right. C minus 28 is 3/2 n minus 6. And now I will add 28 to both sides. and c equals 3/2 n plus 22. And I'll go ahead and write c of n is 3/2 n plus 22, just to be consistent with what was given. Now look at that. What's the y-intercept? 22. And I started off by saying, well, is the y-intercept 22? We weren't sure. It turns out that it was. But you don't want to make that guess in the beginning. You want to use the vertical intercept to verify your work. Find the equation of the horizontal line that passes through 7, -4, and sketch its graph. I'm actually going to do this in the other direction. I'm going to sketch the graph first. Alright, so passing through 7, -4, well, here's the point 7, -4. The horizontal line through 7, -4, the horizontal line is the line that goes, just left, right. It doesn't move up or down. So there's the horizontal line. Now, every horizontal line has the same general form. Horizontal line, y equals just a number. So, in this case, the y value is always -4, y equals -4. There's the equation of the horizontal line. Alright, find the equation of the vertical line that passes through -2, 5, and sketch its graph. Again, I'm going to sketch the line first. Alright, so there's -2, 5, and let me draw the vertical line through that point. That doesn't look very good. Let me try again. That's slightly better. Alright, so there's the vertical line through the point. Every vertical line has the general form x equals a number. And in this case, the x value is always -2, so x is -2. And notice earlier we said that was not a linear function. Even though it is a line, it is not a linear function because, notice, it doesn't pass that vertical line test. All of those points on the line have the same input. So we have one input, -2, with many outputs. And so it's not a linear function. Alright, another special case, parallel and perpendicular lines. We say that two non-vertical lines are parallel if and only if their slopes are equal. And so then the slopes of the two lines would be the same. M1 and M2 would be equal. So for example, if the slope of a line is 2/5, then the slope of any line parallel to the given line is also 2/5. We say that two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. So M1 is equal to -1 over M2, or equivalently, the product of M1 and M2 is -1. So for example, if the slope of a line is 2/5, then the slope of any line perpendicular to the given line is -5/2. Notice that 2/5 times -5/2 is -1. Alright, we want to find the equation of a line in slope-intercept form. And now, let's see what we're given. The line passes through -1, 4, and is parallel to the line passing through 3, 6, and -4, 8. Alright, so the first thing I need to do is find the slope. Alright, I need a slope. Well, the line is parallel to the line passing through those 2 points. So if I find the the slope of that line, the slope of the line I want is the same. All right, so I'll say M1, all right, for these points. M1 is negative 8 minus 6 over negative 4 minus 3, which is negative 14 over negative 7, which is positive 2. So M1 is 2. Now, since they're parallel lines, M2 is also 2. So I have the slope, and the line is passing through negative 1, 4. I'm going to write a point slope form. Y minus 4 is 2 by x minus negative 1. I will simplify, apply the distributive property, and add 4 to both sides to isolate the y variable. And that gives me y equals 2x plus 6. Well, let's look at another example. The line passes through negative 1, 4 again, but now the line is perpendicular to 12x plus 2y equals negative 18. Again, I need slope. Well, I know that my line is perpendicular to this other line. So let's find the slope of that other line. Now, since they gave me an equation, I'm going to take it to slope-intercept form. So I have what? 2y is negative 12x minus 18, and I'll divide through by 2, and y equals negative 6x minus 9. So M1 is negative 6. Perpendicular would tell me that M2, the slope of the second line, would be positive 1/6. So now I have a slope, I have a point. I'll write a point slope form. Y minus 4 is 1/6 of x minus negative 1. So y minus 4 is 1/6 of x plus 1. Applying the distributive property, y minus 4 is 1/6 x plus 1/6. Now I'm going to add 4 to both sides, but I need a common denominator, so I'm going to add 4 in the form 24 over 6. So then y equals 1/6 x plus 25 over 6. All right, we'll end off the section with an application. We're told that the number of vendors at an open-air market has been decreasing due to a steady increase in renting fees. In 2003, there were 310 vendors, and in 2008, the number dropped to 195. Let x be the years since 2000, and y represent the total number of vendors in the market. So the first thing I'm going to do here is I'm going to write some ordered pairs. Now, since x is the number of years since 2000, so then my first ordered pair would be 3, 310, because 2003 is 3 years after 2000. My second ordered pair would be then 8, 195. All right. Assuming that a linear function models this data, find and interpret the rate of change. The rate of change is just the slope. We can find the slope. M equals 195 minus 310 over 8 minus 3. All right, 195 minus 310, that's negative 115 over 5 is negative 23. So there's the rate of change. Interpret the rate of change. What does this mean? What's changing? something is decreasing. What decreased? Well, what are these numbers? What are the 195 and the 310? The 195 and the 310, those were vendors. That was the number of vendors. And what was the 8 and the 3? Well, that was years. So what are the units on that negative 23? The units would be vendors per year. All right, interpret this rate of change. The number of vendors at the market is decreasing at a rate of 23 vendors per year. Notice I did not write negative 23 vendors per year. I've already taken account of the negative by saying that the number of vendors is decreasing. So since it's decreasing, we don't use the negative in front of the number. Okay, part B. Find a formula for this linear function in slope-intercept form. All right, I have the slope, I have a point. Y minus 310 is negative 23 by x minus 3. Y minus 310 is negative 23x plus 69. And I will add 310 to both sides. Y equals negative 23x plus 379. And that's a function. We could write f of x if we wanted to, but I'll just leave it as y equals. So y equals negative 23x plus 379. All right, so now that we have that model, let's answer a couple of questions. Part C asks us, how many vendors were left in 2005? So 2005 means that then x was 5. So then y would equal negative 23 by 5 plus 379. And going through that calculation, we get 264. Conclusion. There were 264 vendors left in 2005. In what year can they only expect to have 11 vendors left? Well, y is the number of vendors, so let y equal 11. And so 11 is negative 23x plus 379. I'll subtract the 379. So negative 368 is equal to negative 23x. And I'll divide through by negative 23. So 3 gives me 16. So this implies that x equals 16. All right, so now what does that mean? Remember, x is the year since 2000. The market can expect to have only 11 vendors left in 2016. Identify and interpret the y-intercept in terms of the problem. Well, identify, that's easy. The y-intercept is 0, 379. Well, what does that mean? Remember, x is the years since 2000. So if x is 0, that means 0 years since 2000, which means the year 2000. Conclusion. In 2000, the market had 379 vendors. That concludes the presentation for section 1.5.